This next video that you're going to watch is arc length. And what I'm going to show you is how to find the measurement, or actual measurement of an arc length. So if we look at our picture, what I'm going to do is I'm going to show you how you can find the length of arc AB. If you look at the arc AB, you see that this arc is a portion of the entire circumference. So the way we set up our equation is we set it up as a proportion, and it looks like this. The length of your arc over, and if you will remember, this is circumference of a circle, the formula for circumference of the circle, will be equal to the measure of the arc, which would be its central measure, over the total measure of your circle of 360. So let's take a look. Alright, we're going to find the arc length of this arc. So let me just kind of highlight. So we're going to find the arc length from here to here. And we're going to come over here and we're going to set up our proportion. The length of AB is going to be what we're going to find, so we're not going to put a number right there. Down here, we're going to use our circumference. We're going to replace the R with the actual radius. Over here, the actual radius you see is 5. That's going to be equal to the measure of arc AB. If we look back over here, the measure of arc AB is the 50 over the total of 360. So let's set that up. And there we have it. The length over our 2 times pi times radius equal to our 50, which is the measurement of the arc angle, over 360. So we would cross, multiply those. So 2 times 5 is 10. 10 times 50 would be 500, equal to 360 times L. And then we would solve that, and we would get that the arc length is 1.38 times pi, or we could multiply that out completely and get 4.36 centimeters. And your answer will depend on what they want. Do they want the answer in terms of pi? You would choose this answer, or if they want it completely multiplied out, and that would be this answer. Let's look at our next one. We're going to find the arc length, and we're going to give our answer in terms of pi, and make sure that it is rounded to the nearest hundredth. Okay, so we're going to use our standard proportion, the length of the arc over the circumference, equal to the measure of the arc over total degrees of 360. So we're going to look at the length of FG, arc FG. So from here to here, FG, this is where we're actually going to look at. Now we could, if you wanted, you could draw in the radius for those, but you already have it here, which is your 8. So we're going to come over here and set this up. So the length will still be the unknown. Your radius of 8 times the 2 for the 16 times the pi equal to our measure of 134 degrees over the total of 360. So we're going to cross multiply, and then we're going to divide, and we get 5.96, and I have rounded that off to the nearest hundredth, and I have left it in terms of pi. If they wanted you to go further, you would just multiply that pi out, and you would get 18.71. Okay, and that's it. That's how you find the length of an arc. On this slide right here, I would like for you to set up these two arc lengths proportions, and I want you to solve them. So go ahead and pause the video, work the problems, and then turn it back on or restart it and check your answers. Okay, I hope that you've answered both of them. Let's see if you got your answers correct. Let's take a look at the first one. The arc AB over 4 pi, so the 4 we got because we had a radius of 2 times the 2 here to give us the 4 pi. And our 62 measure of 62 over the total of 360, and multiply it out. And your last one down here, you're set up your arc length over 8 pi, that is the radius of 4 times 2 to give us your 8, over the arc measurement of 135 over 360. You multiply those out and divide, and you get 3 pi. I hope you did it. I hope you got the answers. If you did not, go back and rewatch the video and see where you made your mistakes. I will post some other problems for you to do along with this.